Okay, so we're doing fraction division now. And to begin, of course, we're going to go into familiar territory and remind ourselves just what division means. And so I want you to take a moment, pause the video, and think about, see if you can come up with at least 3 different things that are meanings of 6 divided by 2. Okay, so there's a couple ways to see division. One is how many 2's can fit in 6. So there's how many groups of 2 or how many 2's. Another one is if you break 6 up into 2 equal groups, then how many will be in each group? And the third common one is basically a fill-in-the-blank multiplication. 2 times what number equals 6? Okay, and this, recognizing this as a fill-in-the-blank multiplication actually covers these other 2 conceptual meanings, because you can see multiplication as so many groups of whatever. So this says 2 groups of what number? So that's the second meaning. Or you can say how many groups of 2. So that's the first meaning. Okay, so again, taking these ideas, I want you to pause the video and think about what pictures you can make that depict 6 divided by 2. And there's a few different dissimilar pictures that are going to show that. Okay, so the pictures that I have pre-made, I'm not going to draw them. So you can look at drawing objects. So this is if you divide, the first bit is if you divide 6 into 2 equal groups, it'll show that there's 3 in each group. Or if you ask how many 2's there are in 6, there are 3 2's. And here are number line depictions of the same concept. So if you split 6 into 2 equal groups, basically splitting 6 into half, then there are 3 in each half. And then the other way is if you ask how many 2's are there in 6? Well, there's 1, 2, 3 2's in 6. Okay, so these are important meanings that we're going to keep with us as we start to divide with fractions. And I also want to remind you, since we're in fractions, that we have also seen that 6 divided by 2 is equivalent, 6 divided by 2 is equivalent to the fraction notation 6 halves, okay? And so we can also see this as a picture of, I mean, it's a little less so, but we can go a half 6 times. So there's 1, 2, and it takes 6 halves to get to 3. Okay, so this kind of brings us to the notion that 6 divided by 2 is the same thing as 6 times 1/2. Okay, 6 halves we saw can be written as 6 times 1/2. So there's 2 main points that I want to highlight in this example so that we can bring these forward to the division of fractions. One is the connection between the division equation 6 divided by 2 equals what, and the multiplication equation, 2 times what equals 6. Okay, that's going to help because we have our meanings of multiplication. This is 2 groups of how many, or how many groups of 2. Okay, and the other is the connection between the division expression, 6 divided by 2, and the multiplication expression, 6 times 1/2. And on this piece, I kind of want you to notice that this is something that we use in our language. This is something that we're actually familiar with in practice, in that dividing by 2 is the same thing as taking half of something. Okay, so this notion of dividing by 2 being the same as multiplying by 1/2 is something that we're actually familiar with in our practice. And similarly, like if I was talking about fifths, like dividing by 5 is the same thing as taking 1/5 of. So division by 5 is the same thing as multiplying by 1/5. Okay, so moving on, and I'm going to, okay, so now we're going to try 6 divided by 1/2, okay, and I want you to pause the video again, see if you could come up with 3 different definitions of 6 divided by 1/2, and you might basically start by just straight up translating these 3 meanings of 6 divided by 2, and you'll have to change the language a little bit partly because it doesn't make sense to have groups. But see what you can do to come up with a meaning for 6 divided by 1/2. Okay, so one way is to say, well, how many halves are in 6? Similar, like how we said 6 divided by 2 is how many 2's are there in 6. So now this is how many halves are there in 6. And as you're thinking about these meanings, also think about what the answer would be. And the other one, which was in the 6 divided by 2 case, it said if you divide 6 into 2 equal groups, and you can't really divide 6 into a half of a group, but if you think about if 6 represents half of a group or half of a number, what is that number? Okay, and both of these are represented in the multiplication fill in the blank equation, which is 1/2 times what number equals 6. Okay, so this is half of what number equals 6, that's the second meaning, or how many halves are there in 6? Okay, so again, pause the video, see if you can come up with some pictures of 6 divided by half using these meanings. Okay, and the pictures I came up with, again, there's pictures of objects, So if I want to know how many halves are there in 6, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 halves in 6. And this is again represented on the number line that it takes 12 halves to make 6. Okay. The other one is, if 6 represents half of a number, then what is that number? Well, 6 is half of 12. Okay, so this is the picture that shows that. Okay, similar to the case of 6 divided by 2, we want to notice some important things here. And one is the connection between the division equation 6 divided by 1/2 equals what number corresponds to the multiplication equation 1/2 times what number equals 6. And there's the other one, which is, you notice that in order to figure out how many halves there are in 6, you're essentially needing to double 6. And that comes out in both of these meanings. You can take a moment to pause and reflect on why the answer to this question comes from doubling 6. So you also have a correspondence between the division expression 6 divided by 1/2, and that corresponds directly to the multiplication expression 6 times 2. And so similarly, if we were to ask, for example, what is 6 divided by 1/5? You could ask, well, how many fifths are there in 6? Well, there's 5/5 in every one whole. So that would mean 5 times 6 is 30/5 in 6 wholes. So this is, thinking about this as how many fifths are there in 6? And the other way around is, if you ask 6 is 1/5 of what number? Well, 6 is 1/5 of 30. So this, again, corresponds to the multiplication equation 6 times 5 equals 30. Okay, so there's a lot of swapping back and forth in between different perspectives to make in order to see all of these things. So it might get a little bit confusing, and that's normal and natural. And just take a little time to sit with it and allow yourself to play with it a little bit. Allow yourself to be confused, but see if you can grasp some aspect of this. And but all of this should be hopefully enough to convince you that it kind of makes sense that if I was to take any number and divide by a fraction, then it's the same as multiplying by the reciprocal of that fraction. Okay, so any number, if I divide by a fraction, it's going to be the same as that number times the reciprocal. So A over B and B over A are called reciprocals. And I'm not going to go into the full reasoning for this, but this is basically enough to, I think, convince you that it's that it is believable, it is reasonable. And if you want, I will try to find a video that shows the full aspect of it. But basically, we divided by 2 and saw that it's the same as multiplication by 1/2, and divided by 1/2 and saw it's same as multiplication by 2. And basically combining these, it'd be, dividing by any number is the same as multiplying by its reciprocal. And so I'm going to put this in writing. Dividing by any number is the same thing as multiplying by its reciprocal. Okay, so let's do a couple of examples. And I want to first think about like interpreting the meaning of these fraction divisions, and then and see if we can come up with an approximation before we actually get our results. Okay, so 9/4 divided by 3/4. This is 9/4 divided by 3/4. So we could ask how many groups of 3/4 are there in 9/4. And here's a funny thing about this. Since if we're looking at these as fractions, then it's how many groups of 3/4 are there in 9/4. And again, with the meaning of these fourths, fourth is just a name of a size of piece. So we could just as easily ask how many groups of 3 cats are there in 9 cats. And if you ask that question, it should be clear that the answer is 3. Okay, and we can do a picture of it if you have fourths, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 9/4, which would make this 2. 1, 2, 3, 4. There's 1. And if you ask how many groups of 3/4 are there in 9/4, there's 1, 3/4, 3/4, 3/4. There's 3 groups of 3/4 in 9/4. Okay. You could also ask, well, 9/4 is 3/4 of what number? And that one, I think, is a little bit maybe more of a mental stretch to think of just mentally. But it will also be 3. 3/4 of 3 is 9/4. And so let's do the operation. So 9/4 divided by 3/4. And again, we're dividing by 3/4 here, and dividing by 3/4 is the same as multiplying by 4/3, the reciprocal. Okay, and when I multiply these, I multiply numerators and I multiply denominators. I'm going to not multiply them through until I cancel common factors. And so we can see we have a common factor of 4 here. And so this is the same as 9 divided by 3, which is 3. Okay. Let's do this other one. So 5/8 divided by 1/3. So you might ask how many groups of 1/3 in 5/8, and I would say, very rough estimate. I'm going to go from 0 to 1 here. 5/8 is just a little bit more than a half. I'm just, without any precision, I'm just going to say it's about here. And 1/3 is like here. And so if you're asking how many thirds are there in 5/8, well, I think it's reasonable to guess there's like between 1 and 2. So if we were to estimate, it'd be 1 to 2, maybe 1.5. Okay. So let's do the multiplication and we'll figure it out, or do the division. So 5/8 divided by 1/3 is, dividing by 1/3 is the same as multiplying by 3/1, the reciprocal of 1/3. Okay, and so this is 5 times 3 divided by 8. There's no common factors because the prime factors in the denominator are only 2, and the prime factors in the numerator are 5 and 3. So this is 15/8, which, if you convert this to a mixed number, this is the same as 1 and 7/8. So it's between 1 and 2. It's pretty close to 2. And if we were to have a more precise picture here, then we could probably even see how close it would be to 2. Okay, so 1 and 7/8 is an acceptable answer, or 15/8 is an acceptable answer. Either one of these is a perfectly fine answer. All right. Oh, look, I guess I gave myself number lines here. Haha. All right. So yeah, let's actually do this. I'm gonna leave the first one to you, but if you were to see, let's see, if I want to be able to see eighths and thirds in the same unit, then I probably want to divide my unit into 24 equal pieces. So here is 0, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8. So this is one where I have divided into eighths. 1/8, 2/8, 3/8, 4/8, 5/8. So here's 5/8. And now if I choose a different color, then thirds is each 8 tick marks. So 3, 6, 7, 8. There's a third. And 3, 6, 7, 8. There's another third. There's 1/3 and 2/3. And now you can see that to get to 5/8, you go 1/3 and almost 2/3, but it's another 7/8 of a third. So it's 1/3 and 7/8 of a third is 5/8. All right, so I guess that's it. The moral of the story is dividing by fractions is the same as multiplying by their reciprocals.